symbols and truth tables. So the truth tables is like a true or false. If a given statement is a true or false. So that's what we're basically learning today. And there are a lot of logical things on this one too. Now, in this one, the concept behind here is basically we're looking at the truth tables. So the truth tables is, let's say, for example, let P be the angle is a right angle, then Q be the measure of the angle is 90 degrees. What are we doing here is we took this one, the first one, the angles in a triangle, the angle is a 90 degrees, or let me do it again. If the angle is a right angle, so that is the statement P. And then the other statement is the measure of the angle is 90 degrees. That's the other statement. The statement, which is, we can say Q. So what we have here is we have two statements, and one is P and the other one is Q. So when I look at these two statements, now I'm going to write a conditional statement. So the first one is conditional statement. Conditional means just writing as a statement. Okay, and the conditional statement is, you remember the first we learned is like if-then statements in the last exercises. So that's what is a conditional statement means. If P, then Q. So that's the conditional statement means. So if I put a symbols, I'm gonna write it if P, then Q. And then symbols, we write it this. P implies Q. UP, you write it in one arrow and then Q. And if you write it in the words, if an angle is a right angle, so the first one, angle is a right angle, then its measure is 90 degrees. We learned this one already. Remember that?
Yeah.
So we're just basically kind of like reviewing it, but again, we're looking at the truth tables. So whether it is true or not, like that. And the next one is converse. Converse is basically you flip the statement. You flip it basically. You see, that's what we write is if Q, then P. The first one condition is P, then Q, but this one is Q, then P. Then Q, and then implies P. And if you write the statement, if the measure is 90 degrees, then it is a right angle. Next one is inverse.
Okay.
What do we need to do for the inverse? If you remember.
Make it negative.
That's right. So simply we write as a negative that gives me an inverse. So what I did is, but the negative for the conditional statement, not for any other things. For the conditional statements, that's what we're going to write the negative. Negative for the conditional statement. Okay. And not P, then not Q. Yes, the symbol for not is a little squiggly line. The symbol for not is a squiggly line. We call as mathematically, it's called negation. So the negation is, that's it. You can say as negation P implies negation Q. That's how we can say that too. Or if you write words, if the angle is not a right angle, then the measure is not 90 degrees. Okay. And the next one is a contrapositive. The contrapositive is the same thing, but we're going to flip the converse. No, sorry, we're going to flip the inverse. We're going to flip the inverse, then we'll get the answer for the contrapositive. So the contrapositive is just flip the inverse, so you'll get that. This one you flip. And then lastly, biconditional. So we learned this one, biconditional, like double implies. So you see the arrow on the both sides. It's a biconditional. So there's a P and Q. You write it if and only if. That's a biconditional. If and only if. So that's called the biconditional. Okay. And yeah, basically that's the entire thing that we learned. But again, we're putting in such a format that way we can kind of like review it. But next we're going to add the truth tables. So let me get you a question first. and then we can get an idea, and then we'll switch it back to the truth tables. So let's look at an example here. Let the P is the statement is the car is running, and Q is the key is in the ignition. The key in the ignition. So let's look into this first conditional statement, and then we can look at a converse, inverse, contrapositive, and write it down in words. So the first one is P implies Q, and then the converse is Q implies P, and negation P, negation Q. Contrapositive is negation Q, negation P. Go ahead and write it down in the words, and then we'll check that in right now.
So
You were able to say
is A. Okay, so write the converse P equals Q. So the key is in the ignition, then the car is running.
All right, that's good. If the car is, the conditional statement is if the car is running, then the key is in the ignition.
So I said the key is in the ignition, then the car will run.
That's right. Okay, that's a conditional statement. Okay.
And then write the inverse is if the car is not running, then the key is not in the ignition.
Okay, hold on. If the car is not running, okay, that's good. And then the key is not in the ignition. That's good. Very good.
Yep. And then write the contrapositive is if the key is not in the ignition, then the car is not running.
That's right. Good job. Okay. Very good. I like that. Very good. Okay. Now let's look into the truth tables. And then what is this basically is, and then how it is going to help us. It's basically as a logic. That's what we're basically looking at in this. So I'm going to make a truth table for the statements that we have. So, oops. See, I don't want that like. So the first one is P, and this one is Q, and then we can put it P implies Q. So the first statement is P, second statement is Q, and then we're writing a conditional statement for that. Okay, so let's look at the conditional statements. If first one is true, second one is true, and then P implies Q. So let's come with this same example right here. So first one is P, the car is running, it's true. Let's say the ignition is also in there. And do you think it's like both are going to be true? If the car is running, the ignition should be the keys in the ignition.
Yes, it's true.
True, that is true. There you go, that's true. Now the next one is, this is true. Let's say the car is running. So the ignition is not in there. If the key is not in there, what do you think? Is it true or false?
False. False.
False. It is not possible there. Okay? And the next one is car is not running, but the ignition is true. When ignition is on, is it true or false?
False.
It's
false.
It's
like true because like it could just be in run mode, I guess.
Yeah, you don't need to run car to run to put the ignition on, right? So you can be put in the parking and you just put the ignition on and then you turn it on the car. Make sense? And the car is not running and then ignition is off. Is it true?
True.
Possible?
False. Wait. True. True.
Yeah, it could be possible. Like your car is running and also car is not, the ignition is on. So it could be true, right? So that's basically the truth tables. It's like, is it happening or not? So that's what called the truth tables are basically based on. And we can take some other examples and we can see and what happens. It's every situations here. Let's look at the next question right here. Now, making a truth table. So let's make a truth table for the conditions are given to you. Let's say use the truth table to make truth tables for the converse, inverse, and contrapositive. So the first one is given to you, true, 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 false, 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 true, true, false, false, true. So using this table, we can make a truth table for the converse, inverse, and the contrapositive. So let's try that for the converse and see how that comes with it. And we can get some ideas on there. Okay, that's pretty good. You already wrote some of the values out there. That's what we're gonna do it right now. So the first statement is P, and then this is Q, and then P implies. First, when it's P implies Q is for the beginning. We did that already. Conditional statement, we did that. Now let's do it for the converse. Converse means you have to switch them. So that means we're going to look at it. Q implies
Q and P.
Yeah, Q and P right now. Okay, so now this is always there. True, 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 false, false, true, and then false, false. Always these are the same. This P and Q is always
the first one's true then.
Yep, that is true. Yep, agree. And the second one is
false.
True, false, and let's check this one. P means the car is running, right?
Oh, that's a
yeah.
And then ignition is off. So and we're looking at the Q and P. That means false and true. So that's false. Wait. Am I looking wrong?
True.
No, that is true. You're right. That is true. And then this one and implies the other way, Q and P. So the ignition is on. Wait, did I get confusing up there? Let's check it out quickly. So that's gonna be, this is false, and obviously the last one is true. Does that make sense or not really? Based on that, P is the car is running, and then Q is in the ignition. So if the both are true, that means this first one is. Let me check this one. Use the other one.
The ocean leave.
So if we look at that way, the first one is ignition is on, car is running. Is it possible? Both of them? Yes. Possible. And then ignition is false. It's like not. Ignition is not there, and could a car can run? That's the question. And the next one is the ignition is on, but the car is not running. Is that works? So that's what we're basically checking converse. And then we can check the inverse, and then also we can come up with the truth tables for the contrapositive also. The trick is basically true, true is always true. And then false, false is always true. And the only thing is like true, false, false. True and false follows that. And then false, true, true follows true. That's how you keep remember this truth tables. If you look at it here also, true, true, true is true, and false, false also is true. And you see this like true, false, and because we are doing the converse, we got to go to the other direction this way. So false, true is going to come, and then again true, false is going to come next. Okay? So that's a quick trick that you can follow all the time when you do this truth tables. That's first one is P, and then Q. Inverse, both of them are in like negation, so it's an R not. And then lastly is P implies negation Q. So let's see what comes as a truth tables.
Okay, so
the first one is basically true, and then we're gonna have that true, and next one is true, false, and false, true, and then false, false. Okay. So those are the probably the truth tables close there.
Okay, so if the car is not
Let's check it out.
running, then the thing is not in. So the first one's true.
All right, let's check it quickly. So before we move on to the next step, first find out the negation P. Negation P means if this is true, this is going to be false. If this is going to be true, this is going to be false. Okay, and we just put it not, right? If I say yes, then not means no. So if it is true, then it's going to be false, and then it's false.
So, okay, it's going to be false.
So I flipped them. True, that's going to be false. True, and true. Now let's look at these statements. False, false, it's true.
If the car is not running, then the ignition's in. That's probably true.
And the next one.
If the car is not running. Wait. Oh, yeah. False.
And then true, false. That's it. There you go. Good work. So that's for the inverse truth table. Okay. And same way you can make it truth table for the contrapositive. So the best way to look at it, the easy way to look at this kind of like what I call as a truth table, follow the trick. The trick is very simple. This is what you need to look at it. The trick is right here. True, true, true. Oops. Okay. True, true, true. And false, false, also true. And then you follow this one. True, false, and then comes with false. False, false. And then true, true. False, true, it's true. If you understand, then it's easy. These two are easy. True, true are easy, and false, false, both of them are easy because they're all the time same. Only thing is you have to be careful with these two guys. False next is false. True is next to is true. That's why if you remember, then it makes it much easier. Okay? That is called the truth tables. Let's try an example. And we can see if that works out there. Okay, go ahead and try this one. Amar, read this question for me. Amar, are you there?
I'm here.
Okay, read the question. Read it.
Polygon A, B, C, D, E, equal. Can't read. I don't have.
Polygon A, B, C, D, E is irregular.
Equiangular and equilateral.
Equilateral. Polygon A, B, C, D, E is a regular polygon.
Right. So when the polygon is equiangular and then equilateral, it's always a regular polygon. Regular means it has to have the same angles and also has equal sides too. That's called the regular polygon. Okay.
Okay, so polygon A, B, C, D, E is equilateral and
then it is a regular polygon.
Yeah. And then if P is negative, if A, B, C, D, I don't know how to say that word, is not that, yes. Then the polygon A, B, C, D, E is a regular polygon. And then polygon A, B, C, D is not this and that. Then polygon A, B, C, D is not a regular polygon.
There. Okay. That's pretty good.
Is equal, regular and equilateral only if the polygon ABCD is a regular polygon.
Okay. So that's good. So that's basically saying in terms of the words, and then we can create a truth tables for any kind of statement, but always follow the basic truth table of this. This is the main important thing for the truth table. If you understand this, we can write all the truth table. Converse, inverse, contrapositive. Okay, so this is the extension normally. Basically, it is not part of the most of these syllabuses sometimes, but it is an extension. Extension is basically in schools, some of the times, most of the times, teacher doesn't teach this, but it's always good to know that where you go in the test, you will see this type of questions. Okay, that's right. That's what it is for the truth tables.